Hello and welcome back to our discussion on Android app basic components. In the previous two videos, we have talked about layouts, activities, and two of the resources, that is strings and colors. In this video, we'll talk about the themes or style resources, and finally the manifest file. So if you open the styles.xml under resources, this is what it will look like. This file defines the theme for your app, for the entire app, that is all the activities. You can specify activity-specific themes separately, but what you define here will be applicable to the entire app. So what do we see here? We see a style declaration which says its name is app theme and its parent is theme.appcompat.light.dark action bar. So the parent value comes from the default material design, material theme, and this file extends it like inheritance. It extends it and allows you to customize it further. This is a nice way of customizing a theme where you don't have to repeat everything or redefine everything, and you can simply customize specific aspects like the primary color and so on, and leave the other things just as they are derived from the default. So in the given example, the boilerplate code gives you three customizations: the primary color, the primary dark color, and the accent color. So let's see what they signify. The color primary is the color that the quote unquote title bar of your app will take, where the app name goes. And as we'll see later, we can add more controls and navigation on this bar as well. Color primary dark, as you have perhaps guessed, is the notification bar, which is at the top of the screen. It is actually not part of your application. It's a system specific bar where you can see the network status, the time, the battery status, and so on, and several other notifications that typically appear on the left side here. Like this is from the device I use for developing, so it's showing some screenshots that are taken, and the USB debugging is on, and so on. So these are the two places where these colors go. Color primary will also can also be used as at other places by specifying the color or setting a color to that specific color. The third one, color accent, is used in small quantities to provide contrast, like when you have a selected radio button or checkbox and so on. That's where it can be used. Next is the drawables. Drawables are static images that are mainly used as icons on the launch screen or for background of the app and so on. And there are two ways you can define drawables. One, it can be an image by itself. A .png format is preferred. Or it can be defined in XML under res/drawables and then some file .xml. So let's look at an example. This is an IC launcher background.xml, which is a grid of green and then some white lines, which creates the green, which creates the grid. Sorry. And then you'll also find IC launcher foreground.xml, which is which actually, if you look into it, is an XML code, but it renders this Android logo. And what the system does is it actually combines the background and the foreground to create an app icon like this. And you would have seen this icon in, say, the launcher screen over here for our greetings app. This is again the default value, and for now we are good with this, but in later examples we'll see how to create drawables in XML, how to create icons, and how to use them on the launcher. So all the icons you see here on this screen, a screenshot of the mobile phone, it has these app icons created arguably in a similar way, or they could be PNG files also. All right. Mipmaps is an improvement on Drawables. It's used API 18 and above, and it's for better support for different screen resolutions, as well as allowing for square or round icon and so on. So yeah, it supports two variants, and it adapts to home screen settings. So you must have seen some devices which have the round icons instead of the square icons like we saw on the previous slide. So you'll also find these two variants in your project, because we are using API much higher than 18. So, they are already included. This is the square icon and this is the round icon. And if you look at the project tool window, you will see Mipmap, and under that IC Launcher and IC Launcher Round, two subfolders. And inside each, you have 6 files with the same, well, 5 of them with the same name, 6th one still same name but a different extension, that is XML. And you'll see in brackets, in parentheses, several variants, several tags like HDPI, MDPI, and so on. So what are these? So these are basically the same pictures as we see here at the top, but for different screen resolutions. So you'll find the same thing under IC Launcher Round as well. So we'll again come back to this when we discuss UI later, but this is where you can specify the launcher icon for your app and provide different variants for different kinds of devices based on their screen resolution. All right. Finally, we'll talk about the manifest file, which is a way of describing certain essential important information about the app, which is used by Android build tools when your app is being built, as well as the operating system when it's run, and also the Google Play services when the app is installed on the device. So every Android app project must have an app manifest file. It must be at this exact location, app manifests and then, and it must have the exact same name. It must be Android manifest.xml with appropriate capitalization. So what does this file contain? This is what the file of our current greetings app looks like. As you can see, it's an XML file. It has the root element manifest. Inside that, its child is application, and inside that, its child is activity, which is our main activity. So this, as you can see, describes the whole app in a sense. We'll take a look at different parts of this and then see what else can be described or specified in the manifest file. So a manifest file should declare the app's package name. You see it on the third line of this code here. Package equals Android samples.java.greetings. Where is that package name used? Android build tools use it for two purposes. One, it serves as a namespace for your app generated R class. So in the discussion under activities, you have seen how you can do a find view by ID and then r.id. The widget name, for example, the greeting, right? So that R is under the namespace Android samples.java.greetings.r. That's one place where the build tools use the package name to create an appropriate namespace for this generated class. Second, it is used to resolve the relative class names declared in the manifest file. So let's go back. Here in the middle, you see activity, then Android column name equals dot main activity. So that dot main activity is basically again resolved to Android samples.java.greetings.main activity. you can imagine there can be other apps which also have an activity named main activity, and um, this package name then helps resolve any conflicts, or also simplify how you specify the activity classes, etc. The package name, by the way, should match the base package name in the .java files. So again, going back to your activity discussion, you'll see the same package name is at the top of every file saying package and then the package name. Okay, so all your activity classes are inside that base package. There can be sub-packaging, but the base package should be the same name. Finally, this app package name is also used um, after the app is signed and built, signed, and delivered. So its value is replaced with a unique ID, a auto-generated ID that is used to identify the app on Google Play and on your device, etc. So, for example, when you push a new version, instead of installing a new app, it basically pushes the new version on the device by matching this unique ID, which replaces the existing one, for example. Okay. The second thing the manifest should have is declaring all the app components that are there. So by components, we mean activities, which we have seen a little bit of. Then there are services, broadcast receivers, and content providers. We'll see the three components later. Each component must define its Java class and any intent filters that describe how this component can be invoked. So intents is the message passing mechanism inside Android. And you can pass intent from one activity to another, or an activity to a service, or a broadcast receiver to activity, and so on. We'll talk about intents later when we build a new app as an example and add a second activity in that. So we'll launch the second activity using an intent. Okay. Let's quickly look at the manifest file and see where we declare our activity. So this is where it is. Okay. Activity, Android name, and .main activity, and then you have intent filter. You have two of them. There is an action filter and a category filter. And the action filter here says this is the main activity of the app. So that will be the first activity to open when the app is launched in a standard way. That is, for example, by clicking on its icon from the launcher screen or the home screen. And the second filter here is a category. Category is launcher. What it means is this app should be placed on the launcher screen of the device. So what that means is, perhaps you won't do it for most of your apps, but you can have multiple activities whose category is launcher, and then all of them can be an entry point to your app. And all of them will show up as icons on your device. So, not something you'd usually do, but it is possible if it makes sense for your app and the project. All right. The manifest file should also declare apps permissions. We don't have an example of this in our current app, but what do permissions mean? So you'd perhaps remember from our discussion on the Android architecture that each app basically works in its own sandbox. And then the question is, how do two apps interact with each other? Can app one ever pass data or invoke some things in app two? Well, and the answer is yes. I mean, for example, you can send SMS, which is sending SMS text message is an app, inbuilt app on the device, and you can trigger that from your app, for example, right? So the question is, how does Android allow certain actions and does not, and restrict certain other actions? And the mechanism is using permissions. So certain protected parts of the system or other apps, are masked by permissions. So your app must declare if it is going to use any of these restricted permissions. For example, network access, sending SMS, and so on. Another use is if you can declare that your app requires these permissions. So if a third app is trying to invoke some part of your app, it must request those permissions first, right? So we'll see an example of declaring permissions for, say, sending SMS. So inside the manifest, you know, you will. So as a child of the manifest itself, you'll at some place you'll declare users permission, and then it can be something like Android name equals Android permission senders underscore SMS. Um, um, More recent versions of Android, Android 6 onwards, they allow runtime permissions as well. So before that, what used to happen is when you install an app, it will give you a list of permissions the app is requesting, and the user gets a choice to declare, or rather, allow the permission or not allow the permission by basically deciding whether to install this app or not. Later versions of Android, what they do is if you are doing certain action, like if you want to use camera, at that point it will prompt and ask for those permissions at runtime instead of asking to allow those permissions at install time. And the rationale is, well, you may want to use this app for almost everything else, but maybe not using camera or maybe not sending SMS. So you should be able to do everything else, but when you want to send the SMS, it can prompt for the permission. And if the user says okay, then you basically trust the app to use your camera and go ahead with it. Okay. So that's the idea behind permissions. All right. And final thing the manifest must declare is the app's compatibility info, if applicable, of course. So what do you mean by compatibility? Once again, we'll talk about this in details later, but it can be some hardware and software features. For example, an app that requires, say, accelerometer should not be installed on devices that don't support accelerometer. So such information can be included in the manifest, and then Google Play Store will decide whether the device supports it and whether it should even install whether it should even allow to install the app or not. So you might have seen things like, okay, this device does not support this particular app or things like that. So that's where it's coming from. Another aspect is, of course, software features, which could mean a specific API version. So apps that don't support um, uh, features for, say, the latest API should not be installed on a device that is running the latest API. Okay? So again, these things can be specified in manifest, and they'll be checked at the time of install, and will be either available or just not available to be installed on those devices. So again, we don't have any example of this in our current Greetings app, but this is how you can specify it. So again, under manifest, you can say use this feature, and here it says Android hardware sensor Compass. So this app is going to use Compass, so it should not be installed on devices that don't have Compass. Okay, yeah, and it's required true, so it should be checked at the install time. All right. Finally, some other interesting attributes on the manifest file here. So first of all, the allow backup attribute is by default set to true. What it means is it will allow creating backups, as it says. If it is set to false, it won't allow any backup or restore of this application, even when a full system backup is taken. Okay, so that is largely for managing backups. If it's true, then the backups will be taken by default, and um, a little bit of hint. This will be, you'll get a chance to look deeper into this in your next homework. So there will be a homework announced soon, in which you'll have to do some research online and figure out what all happens when it says allow backup. Okay. Next, you see the icon, which is from the Mipmap, so you can guess what it will be, the IC launcher, and that's how the icon for this app shows up on the launcher screen. Um, and then it also gives the round icon, which is the IC launcher round, both versions of it. This supports RTL is true, and RTL means right to left for supporting languages like Hebrew, Arabic that read right to left. And this was added in API 17, so devices or apps with versions below that will not have this attribute. All right. Yeah, so this is where we specified the theme for the entire app. We saw what theme is a little bit before, and this specifies the theme for the entire app. You can customize it further for each activity down here later. And finally, we have also seen the string attribute, string resources earlier. Here it says Android label is string app underscore name. If you remember, app underscore name is greeting in the string file. And this is an example of using the add string resource in XML. This is how you'll use it. And even when you put the greeting or say the welcome or good morning um, on a text view, this is how you'll be using it.